Hello, hello, hello. This is a test. Can you hear me? Hello, hello. Yes, you can. Hello, hello, hello. Can you hear me? A little bit quiet. Maybe I should go up a bit. Yes, you can. Oh, I can't. Hello, hello, hello. Oh well, whatever. This'll do. Maybe I'll go a little bit closer here. Oh, actually. Alright, so I don't really remember much of where I left off. Once again, trying to do some game development, a bit busy at work, but we'll pick up okay. Something about um God. There's definitely something about the electron positions, trying to figure out the wave function, I guess. Maybe we're trying to do a bit of coding to help me kind of create some way of analyzing his stuff. I think it was that kind of thing. So, but anyway, first of all, as always, let's just start with a Greek lesson. So let's do that. Match the pairs. SEO, this is this sigma. So
Σιο,
SEO. Score.
σκο,
Score. Kus.
κους,
Me.
με,
Sin.
συν,
Susanna. That will be sigma. Susanna.
Σουσάνα,
Susanna. Okay, so you stretch the A. Susanna. Kus.
κους,
Kus. Yes, the toast.
ναι,
Ne.
το, toast,
Toast.
Σουσάνα,
Write this in English. Susanna. I don't know how to spell.
Σουσάνα,
Okay. U. Two N's. I don't know. It's a name. The toast is a snack.
το,
Toast.
toast, είναι,
Ine. Snack.
snack,
Snack. Το toast είναι snack.
κους,
Kus.
κους,
Water in the couscous. Nice.
νερό,
Nero.
στο,
Sto. Yeah, got that one wrong. Sto. Couscous.
κουσκούς,
Couscous.
κους, κους, Σουσάνα, το κουσκούς,
Susanna. The couscous.
Σουσάνα,
Again? Oh, it's an A. Susanna the couscous. Select the correct characters for score. Sigma again.
σκο,
Score.
σκο,
Score.
σκο, σκο,
Score.
σκο. Αυτός κάνει τόστ και κουσκούς.
The man. Something toast and couscous. The man. What's carne? Ah, what is that? Carne. The man. I can't remember.
Κάνει,
Makes.
κάνει,
Doing equals. Makes carne. Okay. The man makes toast and couscous.
τόστ με καρότο.
Ah, he. Okay, fair enough. Toast. Meh and carrot. I don't know if that is
Με,
and. Toast with. Meh. Okay. Toast with carrot. Sorry. Yeah, toast with carrot. Meh
Toast.
is with.
αυτός κάνει τόστ και κουσκούς.
He makes toast and couscous. Oops. Αυτός κάνει toast και couscous. Let me just close the. Oh well, I can't really. I think I'm being quite loud, but oh well. It'll have to happen. Ooh, awesome. So we're on to the next set. That's good stuff. Right. Yeah. So just a quick one. I thought it was quite cool. I have because I'm diabetic, I have had my booster vaccine, and it was Pfizer one. Yes, I got the Pfizer vaccine. Um, I like this leaflet though, because it's like uh uh like it's a bit of a shame because I think advertising these kind of things with maybe a you know perhaps a variation of age would communicate better that everyone should be having this. But anyway, good stuff. Not the booster, but yeah. Cool. Okay, so yes, excited about that, and it's inspired me to do more of this work. Okay, cool. So what the hell was I doing? Is the question. I see. So, oh yeah, we were discussing. Ah, yeah, yeah, yeah. We were discussing that if there is. Can you see this? Can you see this? I think I do need to close the window. Oh, all right. It's just because my landing like echoes the sound out into the other apartments, so it's not that great. Yeah, so what we were doing was stating that there are so many different possibilities. I don't know if it's infinite, but um, certainly a large number of possibilities where an electron could be based on another atom's electrons. And so it brings to mind that I need to solve the problem with machine learning and some good data sets, right? So that's what we'll do. And I guess I need to just bring up interesting, can't close that. I also need to bring up the code, so let me get that up. Visual code. Oh yeah, it's all perfectly here still. Let's see if this runs. Downloading package, OmniSharp. Can you see this? Kind of? Maybe? Probably. Uh, yeah, you can. Okay. Sorry, there was such a delay on the camera then. I was like, oh, that's weird. Okay, cool. Yeah, so I'm just trying to see if this runs. Oh, and it does run. Great. And we were going electrons. Oh, yeah, that's right. So n is the size of the orbit, shape of the orbit, orientation of the orbit. And these, I give them numbers. Uh, and I don't think I've done all the other ones yet. Oh, no, I did. Yeah, exactly what I did. That's right. So, um, let's see. I have to remember this now. So, the principal quantum number, uh, L must be 0 to that? What's 6 do? Let's see. 3, 1. Try that again. It is changing it. Okay, I'll have to remind myself of what that rule is. I think it was on here. Yeah, 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 okay. And in fact, I should write it down somewhere good. Let's go episode 21. Problem solving skills. Oh yeah, that's good. Yeah, cool. Here we go. The three coordinates that come from Schrodinger's wave equation are principal n, angular L, and magnetic M. And the 0, 1, 2, 3, and so on. The principal quantum number n cannot be 0. The allowed values of n are therefore 1, 2, 3, 4, and so on. The L can be any integer between 0 and n minus 1. Okay, n minus 1. Fine. And, oh, well, maybe let's put that in there. Might be a waste of time. I should really know that if I'm gonna do this seriously, right? So Recent forms. Let's see what we got though. Main window. Oh yeah. Let's do it. So let's just put this in. Shape of orbit. Um, 0 to n minus 1. And then m is minus L and plus L. Minus L to plus L. Good. Cool. Save form, view Python code, copy, paste through. Definitely not that one. Windows, widgets, Qt, that's the one, widgets, Electron's widget, Pi. Let's try that out. Stop and play. Just helps me next time, I suppose. Cool, okay. And this was zero. This is what again? 0, 1, 2, 3, or was it 1, 2, 3, and so on? Let's go and have a little look again. Okay, so greater than 0. Let's just put that as well. Make life easy. For future James. Nice. I will check it because it's late again and I'm always a bit tired doing these things, so I probably make mistakes. Okay, cool. That's a good start. What's the next thing then? So if I plug some of these things in again, remind myself if I do 3, then that should be oh, that's interesting. So when did I do the, because I did something else about making the right letter come out. Um, where did I put that stuff? Oh, it's a bit hot now. I've closed the. 1 second. All right, we're back. Yeah, so I did some work on this where it was producing the correct letter. I don't know where that work's gone, so let me just try and find that as well. Is there a way to list all functions? Is it this one? Yeah. Validate M with define shell letters. Here we go. So did I remove this or something? So this must be, this debug. What's debug? Debug Python in terminal. Or maybe it debugs automatically. Okay, cool. So what happens here? Fetch list of shell letters for n, principal number. The shell letters are defined as SPDF, and from then on follow alphabetically. Great. Success, here is your Electron output. Oh, that's interesting. So why is that not getting down there? If n is greater than shell letters. Then do this, otherwise shell letters, go and get it from 0 to that. If n is greater than 0, else return 0. Okay. Self dot set output message. What does that do? God, I can't remember any of this. Plain text edit output, set plain text. What does it actually do? Oh, is that not gonna breakpoint for me? Okay, cool. Oh, here it is. So what is this? Plain text edit output. And the message is success, here is your Electron output. Yeah, okay, so it gets overwritten, I suppose. Let's see where it goes. Step over. Returning it. Yeah, then we go and overwrite it. Fair enough. Redefine Electron configuration. Step in. What we got here? Converts an array of Electron configurations into a readable string. So if I come out of here, what we got now? We've got what's this configuration then? So this is doing nothing. After with it, so it should output. Okay, so fine, we got it. We found the problem. Yeah, so we're just we're just outputting and forgetting what we had before. So I suppose what I should do is append. So let's rename this. Where we got this? Ooh, lots. Yeah, let's do another function. What are the ones we got? What is this type? QPlain text edit. What we got in there? Append plain text. There you go. Makes sense. Good. Okay. And then importantly, I just need to make sure that I clear out. If it let me do it. So this will be clear out existing message, like so. Whoops. And then we can just go hell for leather here. So append to output message, and this will be append. Right, that solves that problem, hopefully. Good. Yeah, it does. Great. And I suppose if I'm appending, maybe I should, yeah, add an extra line just for happy days, and then we'll get back onto the actual important stuff. Is that gonna muck it all up? No. Oh, that's interesting. So does that already add a line? Interesting. It might. It does. Oh, that's interesting. Okay, cool. Um, that would not have been obvious to me. This isn't mine. No. Good to see there's documentation as always. plain text. Okay, anyway, irrelevant. Cool, so that's all done, and what we're getting out, we are getting out all possible configurations. Here is your electron output, SPDF, and these are all possible configurations, so I need to put that. Five different orientations of orbitals in the 3D subshells are shown in the figure below. One of these orbitals lies in the XY excuse me, XY plane of an XYZ coordinate system and is called the 3D sub XY orbital. There is only one orbital in the n equals 1 shell because there is only one way in which a sphere can be oriented in space. The only allowed combinations of quantum numbers for which n equals 1 is the following. Combination of quantum numbers. So this, okay, so this isn't, so what was a quantum number again? The Bohr model was a one-dimensional model that used one quantum number to describe the distribution of electrons in the atom. The only information that was important was the size of the orbit, which was described by the n quantum number. Schrodinger's size of the orbit model allowed the electron to occupy three-dimensional space, therefore required three coordinates, or three quantum numbers, to describe the orbitals in which electrons can be found. So it describes the orbital configuration. Maybe. The principal quantum number, n, describes the size of the orbital. Orbitals for which n equals 2 are larger than those for which n equals 1, for example, because they have opposite electrical charges. Electrons are attracted to the nucleus of the atom. Yep. Energy must therefore be absorbed to excite an electron from an orbital. Energy must therefore be absorbed to excite an electron from an orbital in which the electron is close to the nucleus, n equals 1. Yeah, we've got that. Into an orbital in which it is further from the nucleus, n equals 2. The principal quantum number therefore indirectly describes the energy of an orbital. Great. The angular quantum number describes the shape of the orbital, blah blah blah. There is only one way in which a sphere, L equals 0, can be oriented in space. Orbitals that have polar L equals 1 or cloverleaf L equals 2, however, can point in different directions. Yeah, okay, that's true. That is true. We therefore need a third quantum number known as the magnetic quantum number to describe the orientation in space of a particular orbital. Yeah, magnetic quantum number, because the effect of different orientations of orbitals was first observed in the presence of a magnetic field. Okay. Shells and subshells of orbitals. Orbitals that have the same value of the principal quantum number form a shell. Orbitals within a shell are divided into subshells that have the same value of the angular quantum number. Chemists describe the shell and subshell in which an orbital belongs with a two-character code such as 2p or 4f. The first character indicates the shell. The second character identifies the subshell. Excuse me. By convention, the following lowercase letters are used to indicate different subshells. Although there is no pattern in the pattern in the first four letters, the letters progress alphabetically from that point, GH and so on. Some of the allowed combinations of the N and L quantum numbers are shown in the figures below. Figure. The third rule limiting allowed combinations of the N, L, and M quantum numbers has an important consequence. It forces the number of subshells in a shell to be equal to the principal quantum number for the shell. The N equals 3 shell, for example, contains 3 subshells. The third rule, limiting allowed combinations of the N, L, and M quantum numbers, has an important consequence. It forces the number of subshells in a shell to be equal to the principal quantum number for the shell. Okay. The n equals 3 shell, for example, contains 3 subshells, the 3s, 3p, and 3d orbitals. I'm not seeing that in my head. What have I just missed? Probably the bit that I didn't read. Orbitals within a shell are divided into subshells. Orbitals within a shell are divided into subshells that have the same value of the angular quantum number. So if I go down here, let's go carry on. There is only one orbital in the n equals 1 shell because there is only one way in which a sphere can be oriented in space. The only allowed combination of quantum numbers for which n equals 1 is the following. There are 4 orbitals in the n equals 2 shell. So if we go n equals 2, we get 2, 0, 0, 2, 1, minus 1, 2, 1, 0, and 2, 1, 1. Good. I wonder if it's worth drawing these suckers. And that would take me on to setting up Unreal Engine for this kind of project. So what I could do is I could output this stuff as like a JSON file and then read it from Unreal Engine and use it to create the orientations. Um, it might not, might not be worth it, but then again, it will give me a real good like understanding of the whole premise. It might waste a lot of time. Um, okay, let's continue. There is only one orbital in the 2s subshell, but there are 3 orbitals in the 2p subshell. There is only one orbital in the 2s subshell, 2s, but 3 in the 2p. So these are being labeled with subshell stuff. Because this is the I'm sorry, what? Let me just what am I reading? Subshells, 2s and 2p. Let's kind of look at this. So these first line is S, second P, D, and this is okay, yeah, so we know that. We know that. But as you go along, 2, 2, 3, 3, 4, 4, 4. L equals 0, L equals 1, L equals 2, L equals 3, 4, 5, and so on. So it's L equals 0 is S. Oh, but, oh, 0 to n minus 1, I see. I see, I see, I see. Okay. Um, and then if, okay, so this is L1 and that is part of P. So I should really output those sections as well. And let's okay, so let's okay, let's just do that first. Let's just also add that part. see if I can get back in the code a bit. Define the shell letters, that's fine. Define shell letters. Rather than just appending them only to return them, great, I do. Returns a list of a string, good. And so when I go and start the operation, I define the shell letters and I get a list of those back. Let's call this shell letters. Excuse me. This coughing's making me want to do a lateral flow test, to be honest. I've got like 6, so I should go and do one. Yeah, so now we've got those letters. That means that we have an array that we can add up to this grouping that we're doing. So generate all possible values for n, l, and m. This needs that information, but does not necessarily need it here. So let's just consider that. Let's go back through to there. So I'm generating all possible values for n, l, and m. And it does a little for loop through ranges 0 to n minus 1, plus 1 for the offset. 0 to n minus 1 plus 1? Care? I wish I'd put a note here. Well, let's just debug it. So n is 2. So we want to do 0 to 2. Why do we want to do 0 to 3? Oh, current L. Because we're going 0. Then we're going to have n minus 1 is going to be 1. So it's going to be 0 to 1. Ah. But it's from the negative. 0 to n minus 1. Let me just whip this out because I can't quite figure this out what the hell that is for, to be absolutely honest. I mean, clearly it's something I want, but what have I done here? This should be really obvious to me. Okay, so I can't drag the window, that's so annoying. Not responding. There we go. That's better. So the current L, what is that? Is okay, that's the iterator. And I go in here and from 0 to 1 to 2. So 0 to 2. So it's going to be three iterations. And so the current L is 0, and then it's going to be the negative to the positive plus 1. I guess because I always want to do one iteration. It's like otherwise it would do nothing, right? So I just get sod all back. So let's just go look at this one. Current M is going to be 0, and n minus 1 is going to be 1, so it's 0 to 1, and you want the negative and the positive, so this should run. Current M is going to be minus 1. And then what? 0, 1. Also, I don't think I've actually put it so that you can pass in L's yet. Yeah, look. L is just left. Generate all possible values for N, L, and M. So why would I have ways of inserting these? These are all possible. So if I did... So this, I don't think it's doing anything, actually. No, not at the moment. Um, just get rid of that. Where is this being used from? Not here. Ah, but these are being passed in, they're just not being used. Okay. So let's just grab post n input. We generate a set of all possible values for L and M. Okay. Well, let's just get rid of that shit then. These aren't being used. Yeah. Okay. So let me try that again. I'm a little bit confused at what this was doing again. Electrons to push. So this was 0 first. So it's going to append 2 for N, 0 for L, 0 for M. But this is supposed to be from negative to positive. So then this is going to be negative because hmm, what does it do after this? Redefine electron configuration is if last L is not current L plus a new line, then last L equals current L. If current M is greater than 0, I mean it's just making it look pretty, isn't it? Current L. Yeah, and let's let that continue again. Let me check my thing out. So this is clearly right. Oh, it's because it has to. It's actually outputting the the initial shell. Yes, so this really needs to be much better. Um, yeah, this should have the shell as well. Okay, good, understood now. Shell letter. Ah, it took a while. Shell letter string. Equals none. Well, wait, will it? That'll do. Self dot shell letter equals shell letter. Okay, good. And this will be coming from the list I've already generated, but to be honest, I could put it in here, so let's just do that. Put that like that, and put that like that. Yes. shell letters will be, it'll be, it'll be L, no, it'll be, the 0th will be the first letter, but then the next section will be, what was it again? M. M is -1 to +1, and L is 0 to n-1. So when L increases, going to the next, yeah, okay, gotcha. Let's do that then. So current L, current L, yeah. Current shell letter equals shell letters current L. This is going to be a string. String is not defined by pylons. Should it be capital S? Is it stra? Stra, okay. Oh, I've mucked that up on over here as well. Oh, okay. I see. So what's the difference between string and... Wait, let's just... I think I've done this before, not that one. Difference between string and stra in Python. String is a module that provides string handling functions. Str is a built-in function that converts an object to a string representation. So I want the import string. Fair dues. Good, okay. Current shell letter is going to be that. Yes. And then, with that, I'm going to redefine this a bit. Going to put the plus on the end and that, like so. Shell letter. Equals current dot shell letter. Yeah. That took a bit of a while, but I think we're not good. Object has no attribute defined shell letters. What? Self.define shell letters. Ah, because it's on the other one. Of course. Let me close that down for a second. Define shell letters is where? There it is. And shell letters. Does this require anything? No. Okay, well that's excuse me, probably good. And this will be a self. Yeah. Okay, let's try that now. Good. 2. Success here is your electron attribute. Electron configuration object has no attribute append to output message. Oh, is that another one on here? Wow, damn. Oh, okay. Well, it makes me think I should have a logging service now. But then this would tightly couple that with the logging service. I don't really want to do that, no. I just want this to return the shell letters. Yeah, and then I'll output after. Yeah, let's do that. Or let me first just comment that out and we'll get back to it. Just want to see if this is working first. Cool. So is that correct? Let me go back to our thing. S&P. And they use the two. I see. I have a proper cough. I'm like dying here. Okay, we're good. What am I doing? This one. Yeah, it would be nice to get this stuff out, but it is now coming from here. So this would have to return the shell letters. I don't think that is really that helpful, because I've already got the shell defined in the output of the configurations. Okay, cool. Yeah, so we will bail on this idea. Yeah. Okay. Well, so let's have a little play with what we just done. Let's go 3 D and then I know 26, 25. Uh-oh, have we broken something again? Because shell letters should be generating that much. What is going on now? What have you generated? 10? Right, and that's because I'm going from 0 to n minus 1. Hmm. So I'm getting 11, but I put in 12. Getting 11, but I put in 12. Yeah, okay. That's not right. Oh, it's greater than 0 though. Ah, yes, okay. That makes sense. Yes, yes, yes. That's right. And so if I go to the shell letters and I'm going to iterate 12 times, I need to make sure that this is not. What? What have I done here? I feel really stupid right now. Let's go down to here. 0. And the 0th is the first shell, which is fine. And n is 12, so we're going to go -1, but then we're plussing 1 again. Because we absolutely want to output the first letter, but maybe that is wrong. Let me just take this out. Still not feeling that. Um, Still not feeling or understanding that. So if I go 2 here, what happens? I get nothing out. And that's because of what? So for every shell there is a subshell. Okay, we know that. So if I go and draw that, I think this is very obvious and very silly, but just getting back into code, I guess. Can you see my screen? Yes, kind of. So if I have a shell, well, actually it'll be. Oh, can I do bigger? Go big or go home. Yeah, okay. So we've got the first shell, and that'll be S, and that'll be for n equals 2, and then it'll be the next one, P or D, whatever it is. SPDF, I can't remember now. SP, yep. SP, that's that's L equals n minus 1 equals 1. So it's from 0 to 1. So we're going to do 1 to get this one. So 1 loop for this, and then 2 loops for that. 0 to 1. Yeah, so this isn't the greatest um, approach here because it's confusing, and this is actually why we've got this +1, because there is what? L1 would be -1, L would be 0, and L would be L. So there is actually 3. That's because of the M. I see. Yes. Okay, I remember. So we've got the L has the L is determined by the amount of M. So let's go here. Current M. So why would we do 0 to +1? Oh man, let me just sit down. Poor little legs. Got this desk now so I can be a bit more comfortable. A bit more healthy, sorry. And hopefully don't crush anything under the table whilst I'm doing it. Cool, okay. Just gonna do a blood test as well. Hopefully you can see me. See my ugly face? Yes, you can. So I understand that problem now. I'm just not sure I quite like the way I've coded it. I'll have to just get my head to agree with it as soon as possible, because I'm sure it made sense at the time. Oh, a bit high. Okay. High in blood sugars. 10.4. I'm supposed to be between 4 and 7.5, so I'll do a little tiny injection to counteract that. It's funny, the whole day my blood sugar's been perfect, and I let loose just the once, and it goes all wrong. Shame. Okay, cool. You can't really see me that well. Yeah, okay. You can't see me that well. I guess I'll have to aim this down then. See if that does it. Ooh, okay. That might have done it. Sure, I'm in the center now. Okay, at least. Right, okay, so I start from 0 and I'm going to go to n minus 1 just for current L. What I should do is maybe just add this straight up. Like, by the way, I have this 1 n to denote, right? Because the first shell is always going to be the n00. Then I just need to iterate over all m's and go back out. So if I were to start from, oh, where's my, there it is. I think it keeps doing this, doesn't it? This funny old program. So if I were to get a nice color out again, let's go for pink, that's always good. We would do one, always one for the N, always one for the S shell, 0, 0, 1, 1, 1. But this, I see, because this increases. So this is always static, 2, but then this has to loop through the L, this has to loop through M many times and iterate up L. But I think it's for each L, how many times do I need to go? So it's like for L, how many iterations do I need to do for 0 to n minus 1? So this is the 0 to n minus 1 loop. And so in this case it's 0 to 2 minus 1, so it's 2 loops. So it's going to go 1 L. And so for the first loop, it's going to say what is the negative of L, which is 0, to the positive of L, which is 0. But we have to do one iteration, but must be one thing, so it must be one iteration. And so with this one, okay, so now we got a 1, right? So this is going to be a 0, 0, 1. These are the indexes. And this is now going to be from 0 to, no, from -1 to 1. From -1 to +1. Let's just erase this. From -0 to +0. And so this equals 3 iterations. So we kind of like force this one in. Force it. Now I think that's where that 1 comes from. So let's go back to our code. Put anyone chatting just to make sure. No, no, okay, cool. Good. Right. Yeah, so here's our loop. So we've got this first n that would be up here, right? But we don't need to do that necessarily because this loop can deal with it. So that plus one uh, deals with the 0 to 0 iteration for L, n at n. What is going on over here? Give me that back. Ah, come on, Microsoft. N at 2, for example, will give 2 L cycles, iterations, 0 to 0 and -1 to +1. 0 to 0 would not allow us room to add to the array. I think that probably makes sense, roughly. Yeah, okay. So with all that being said, now we have this problem of the shell letters. So the current current L will always be plus 1 more than it needs to be. So then that is a problem because I'm going to be running to 2. Because this current L is, it's so interesting because it's almost like I don't really want to do that. I want to do it for. I want to do it before that. Yeah, I'm not sure about this. Let's try this out. I think just up front, just denoting out n. So output n. Oh no. Add to array the s configuration n. The current L will be 0, 0, and 0. And now, if I do this, I'm going to get, so now I've got, let's go green. Now I've got this one done. Now I need to do 0 to n minus 1, which will do these ones. And then this won't get caught up. And then for each 0 to n, we do a negative to a positive. I think that's going to work. I think that's going to work. Let's try with 2. 0, 0. So why has that failed there for the m range? 0. 0 to 0 plus 1. I want to start. Oh yeah, because it's the n minus 1, I see. And so this will be the negative of 0. Yeah, this is a bit confusing. I might need to think about this a bit. Because the problem that we've got here is that the L's start from 0 and yet we're using that to negate that. Let's look at our tool. It says oh, so that's even wrong. I should really correct that. Let me go back over here to 19. No, 18. Because we say here it's n minus 1 and then negative L to plus L, so I should really put that in. Oh, it is L. It's not negative. Okay, well that's not very obvious, is it? It'll have to be. I don't know. I mean, it's just a crap. What's the difference between what? Okay, okay. Not to be mistaken for 1. L is not to be mistaken for 1. Good. Let's do that. Because that did actually just confuse me. Back over here, QT electrons widget. Bish bash bosh. Good. 2. Right, so we're back at this game where the two iterations should lead to this 0 version 2s, and that's what that plus 1 was for. And then this 3 iteration, but now we just added that 1. We've still got 2, so we need to minus 2, but then we're back at the same problem because we need at least 1. 0 to 2, 0 to 1, 1 to 1, 0 to well, okay, that's interesting, so we could do that. 1 to 1. Yeah, and I see where the problem is. Okay, so let's do that, and that's why I did. Okay, well let's just try that out. Do 10. Now it crashes here. List index out of range. Where does it go wrong? Not that, not that, not that. 6 is fine. No, 5. Okay. L4. Because this. Oh, I see. I see. I see. This is the whole output. So this is. Yeah, this is all the configurations that can happen. So we're on 4 here. Now, why would it crash out on that? I'm not sure. Let's have a look. Um, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, how many was it again? 1, 2, 3, 4, 5, 6, 7, 8, 3, 5, 8, 2, 3, 4, 5, 6, 7. There's loads of current L. Why is that mucking up? Why is 6 mucking up? List index is out of range. That's before here. Oh, here we go. Okay. So we've got our 5 letters, 4, 6. Okay. Ah, well, we're not starting at 0 there. But that we shouldn't need to because I'm already going here. So the first letter should be 1 because that is exactly what we want. And so if I go through again, this is now 2, 3, 4, plus 1. That's not even the problem. Yeah. I can't just do. I can't just negate one because that's just dumb. Um, I wonder if a for loop was the wrong choice here. That's why I'm having problems. Because if I did a while loop, I could iterate up each time. Let's give that a try. I think a while might help here. While current L is less than, well, I Less than what though? We don't know up front. We need to go and generate how much we want up front. It's a lot of talking to myself here. Not really doing much interesting stuff. Let me see. So that, I don't think that makes sense. Let's not do that. We need to add this one because of that iteration loop, and I totally understand that. And then if we're going to do that, this is less confusing now because we're going from well, okay. If I do that, even though n is here, we do want to start the 0th thing, and so at least in this case it will be one iteration. And also here, if I did now +1 to offset this initial shell letter index, so to get to, it'll be 1 and then it'll be 2, and 2 would be wrong, so I think it would break at that point. So let's try that. I think that will break. Because there's only 0 and 1, and now we're going to have 1 and 2. So really it should just be locked into 1, 0 to 1, 0 to 1. So maybe that is just one iteration though. Let's just try that again. Yeah, that is just the. No, it wasn't. Okay, let me try that again. So we've got the current L is 0, which is fine because we're plussing 1. And we're getting. Okay, but we should get into here as well, so let's push that again. We do. And this will be from negative L to positive L, but L should not be 0. L can be 0, okay. 0 to n minus 1. Okay, so that's going to be from negative 0 to 0, so I need to do the L at least the one iteration. So almost, I see. So this is interesting, I could do that again, couldn't I? And then that will just remove some of that confusion, I reckon. Add to array the L configuration for the 0th run iteration. And this will be 1. Oh damn it, I'm losing it. That's so annoying. What am I trying to do here? Ah damn, I'm too tired. That's so annoying. I was just getting there as well. Because I'm spending too much time on this really, and it's not a very difficult problem, so I just need to sleep I guess, and I'll wake up in the morning and do it. But then I have other things I need to do. Ah, curse you, time. Just trying to think of a way of doing it nicely. Is This is why this is difficult to think about, because I've not thought about it properly. I mean, this should be really simple. Something like that. Let me just check here, because I swear funny enough, I swear I've already done this kind of diagram. Maybe on 18. Yeah, yeah, I think I did do this. Using the integral for iteration, interesting. Um, that's the series K from F to length A. Length of A is 26 minus n. N is the number we put in, so we put 1 in. Then we multiply the ith index of the A set. 26 minus 2. Oh, what does n really mean? Input principal Q number. Okay, so it is that. So if we put 2 in, for example, that'll be 26 minus 2, 24 from F. The index of F in the alphabet. 5. I think actually this is probably to do with the lettering. Yeah, I don't think that, because I'm surprised to see the 26 there, so okay, let's just try this one more time. So plusing 1 makes sense. Uh, but we've already done up there. And then adding this makes sense, but I'm not sure about that 1 there. But this will be the first. But how many L's will there be? So it'd have to go, this would have to be, because I see, because we're trying to do, for this first L, there will be a 0 to 0, 0 minus 0 to, okay, 0 to n minus 1, that will be 1, 0 to 1, and so the first, okay, so if it's even 800, it's 0 to 800, but we're still going to have the 0th iteration in which we need to force this in. And if we are at the 0th iteration, because I'd really want that to happen, you see. And for 0, we just need to plop it in, otherwise we need to go for it. So I almost need a check here, like if current L is 0, then append this. Otherwise, do the for loop. And this is from 0 to 1, so it's always going to do that. Okay, so at n minus, so at 1, that will still muck things up. So current L will be 0, and that will go to 1, but it's 0 to 1, so it's only do one iteration. So I want to start at 1 and go to 1, so I have to plus 1, but then I need to say if, no, that's actually, oh, okay, fine. I'm too tired for this. Fair enough. It's good to like re-warm up my brain though to kind of thinking about this stuff. So not too much of a waste of time. Yeah. I almost feel like just restarting this loop because it's kind of probably going to flow more naturally. But we'll give it a go. Um, yeah, why not? I could do tomorrow. It's just I've got to think about some stuff. Uh, we'll see how it goes. We'll see how it goes. So not much progress made, but just to dip into the code, a few additions to kind of help me get back into it quicker. Yeah, not bad. Not bad at all. Um, well, with that all said and done, I suppose it's, as always, time to stop the show. So keep learning, keep loving, and I will speak to you soon. Bye for now.